morning students. Before watching this video, please make sure that you have watched the previous videos, especially the last two videos in which we have discussed the content that is necessary for exercise 3B. Already we have started the exercise 3B in which we have finished the first Roman and the second Roman also we have started. So the third question is, show that the equation of the common tangent to the circle x square plus y square is equals to 2a square and the parabola y square equals to 8x or y equals to plus or minus x plus 2a. So the line is tangent to both the circle as well as a parabola. Therefore, it is a common tangent to both of them. So let us suppose that this parabola is y square equals to 8x and the circle is x square plus y square equals to 2a square, and this line is clearly tangent to both a parabola as well as a circle. Given equation of parabola y square is y square equals to 8ax. Given equation of circle is x square plus y square equals to 2a square. So this is clearly of the form x square plus y square equals to r square. Therefore, its center is at the origin and radius r equals to r square is 2a square, r equals to root 2a. Center c equals to 0, 0. R equals to root 2a. So let us take the slope form of the tangent to the parabola y square equals to 4ax is y is equals to mx plus a by m. For y square equals to 4ax parabola, y is equals to mx plus a by m. But for y square equals to 8ax, this can be written as 4 into 2a into x. Therefore, its slope form is equals to how much? Y is equals to mx plus, here between 4 and x, a by m. Between 4 and x, 2a by m. So let the slope form of the tangent to the parabola y square equals to 8ax b, y is equals to mx plus 2a by m. This is equals to y is equals to LCM is m, so this is m square x plus 2a. This is equals to m square x, my is equals to m square x plus 2a. Therefore, m square x minus my plus 2a equals to 0 is the equation of a tangent to y square equals to 8x. Is the equation of the tangent to the parabola y square equals to 8ax. But according to the question, let us suppose that this is first equation. According to the question, 1 is also a tangent to the circle. Why? Because this line is also common tangent to the circle. According to the question, m square minus my plus 2a equals to 0, which is the slope form of the tangent to the parabola, is also a tangent to the circle x square plus y square equals to 2a square. So whenever a circle and a line touch each other, so what is the tangential condition for a circle to touch the line R equals to D. So this is the radius R and D is the perpendicular distance from the center of the circle to this line. And what is this line here? M square x minus my plus 2a equals to 0. This is this m square x minus my plus 2a equals to 0. So this is the radius of this circle. What is the radius? Root 2a. And perpendicular, what is the D? This is D. What is this D here? D is the perpendicular distance from the center of the circle 0, 0 to this line. So since this line touches the circle implies R equals to D is the condition. What is the radius of this circle? Root 2a is equals to D is the perpendicular distance from the origin to from the center of the circle, that is 0, 0 to the line. So m square 0, m into 0 plus 2a by square root of the quotient of x, m square whole square, m power 4 plus minus m whole square, this is plus m square. This is equals to this a gets cancelled. A gets cancelled. So 2 can be written as root 2 into root 2. This is root 2 times. This is m power 4 plus m square is equals to root 2. Squaring on both sides. We get m power 4 plus m square is equals to 2. M power 4 plus m square minus 2 equals to 0. Let m square is equals to t we will take. Then this is m square whole square. This is t square plus t minus 2 equals to 0. Factorization. 1 into minus 2 is minus 2. 2 into minus 1 minus 2. 2 minus 1 is plus 1t. This is t square plus 2t minus t minus 2 equals to 0. Take t in common, t plus 2 minus 1 into t plus 2 equals to 0. So this is t minus 1 into t plus 2 equals to 0. T plus 2 equals to 0, t equals to minus 2. But t is what? M square. M square equals to minus 2 is not possible because m equals to square root of minus 2, which is imaginary, which is not existing. So here t minus 1 equals to 0. So t is equals to 1, m square equals to 1, m equals to plus or minus 1 we get. Substituting this m equals to plus or minus 1 in this equation. Substituting m is equals to plus or minus 1 in y is equals to mx plus 2a by m, we get y is equals to m is plus or minus 1 x plus 2a by plus or minus 1. So therefore y is equals to plus or minus x plus 2a. So that is y is equals to x plus 2a and y is equals to minus of x plus 2a are the equations of the tangents to both a circle and a parabola. The next question is, prove that the tangents at the extremities of a focal chord of a parabola intersect at right angles on the directrix. Which kind of a parabola is not given because we have altogether 9 parabolas. So let us suppose that y square equals to 4x is the parabola. So if it is the parabola, then its then its focus is S a comma 0, and this is directrix x plus a equals to 0. PQ is a focal chord. Since this chord is passing through the focus, it is a focal chord. Now, so this is the tangent at one extremity of a focal chord, which is P. Likewise, this is the tangent at another end of a focal chord Q. So what is the equation of the tangent at parametric point T? Yt is equals to x plus at square. Solution. Let PQ be the focal chord with P at1 square comma 2at1 comma Q at2 square comma 2at2 are the ends of a focal chord. So we have already derived the condition that if PQ is a focal chord, the condition is T1 T2 equals to minus 1. This we have proved. How? S A comma 0, at1 square 2at1, Q at2 square comma 2at2 are all lying on the same line, collinear points. Slope of SP equals to slope of SQ. If you equate it, then actually we will be getting T1 T2 equals to minus 1. That is the condition for the focal chord. Now, equation of the tangent at P at1 square comma 2at1 is Yt is equals to x plus at square. So Yt1 equals to x plus at1 square at P. So here y is equals to x by t1 plus at1 square by t1. So this is of the form y is equals to 1 by t1 into x plus at1. This is of the form y equals to mx plus c. Here m equals to 1 by t1. So slope of the first line is m1 I have taken. m1 equals to 1 by t1. Likewise, equation of the tangent at Q at2 square comma 2at2 is Yt2 is equals to x plus at2 square. So let us suppose m2 be the slope of this tangent, then m2 is equals to how much? 1 by t2. Now, so what is the point of intersection of this tangent and this tangent? The point of intersection of these tangents, this is 1 and this is 2, is of 1 and 2. What is 1 and 2? The equation of this tangent and the equation of this tangent is, simply I'll do 2 minus 1. 2 minus 1. So that is Yt2 minus Yt1. So y into t2 minus t1 is equals to x plus at2 square minus of x plus at1 square. X gets cancelled. at2 square minus at1 square. A if you take common, a into t2 square minus t1 square. So a into what is t2 square minus t1 square? A square minus b square. So t2 plus t1 into t2 minus t1. This is y into t2 minus t1 equals to. So t2 minus t1 gets cancelled. Therefore y is equals to a into t1 plus t2. Substituting a into t1 plus t2 in any one of the equations. Yt1 equals to x plus at1 square, first equation. Then we will be getting what is the value of y? a into t1 plus t2 into t1 is equals to x plus a t1 square. This is a t1 into t1 a t1 square plus a t1 t2 is equals to x plus a t1 square. So a t1 square cancel. X equals to a into t1 t2. Therefore, what is the point of intersection? Let us suppose that R. Let R be the point of intersection. R be the point of intersection of the tangent at P and tangent at Q of 1 and 2. Therefore, R is equals to a t1 t2 comma a into t1 plus t2. So, substituting the condition t1 t2 equals to minus 1, will get R is equals to t1 t2 equals to minus 1 is the condition of a focal chord. So, R is equals to this t1 t2 is equals to minus 1 if you substitute here, minus a comma a into. Now, so m1 is equals to 1 by t1 we get, and m2 is equals to slope of this tangent is m2 equals to 1 by t2 we got. Consider the product of the slopes m1 m2. This is equals to what is m1? 1 by t1 into what is m2? 1 by t2. This is equals to 1 by t1 t2. So 1 by t1 t2 is t1 t2 equals to minus 1. So this is equals to 1 by minus 1. Therefore m1 m2 is equals to minus 1. Therefore these two are right angles. So these tangents are right angles. That means m1 equals to m1 m2 equals to minus 1. That means the two tangents are perpendicular to each other. So tangents are perpendicular. Now substituting R. What is this R? Minus a comma a into t1 plus t2 in the equation of the directrix. In equation of directrix, x plus a equals to 0 implies what is x? Minus a plus a, which is equals to 0. That means this point of intersection R lies on the equation of the directrix. Therefore, the tangents at the extremities of a focal chord, at the extremities means the ends of a focal chord, extremities of a focal chord or right angles at the directrix x plus a equals to 0. Three normals are drawn from K0 to the parabola y square equals to 8x. One of the normal is the axis and the remaining two normals are perpendicular to each other. Then find the value of K. This is the data given. Since this is y square equals to 4x type of parabola, its axis is x-axis. So k comma 0 lies on x-axis. Now, what is a normal? For example, this is a parabola, and at this point P, if you draw a tangent, this is the tangent, and the normal is passing through this P. Normal is passing through this P and perpendicular to this tangent. So this is the normal. From K0 there are 3 normals are drawn. We need to show that one normal is the axis. What is the axis? X-axis. And 2 normals are perpendicular to each other. So, given parabola is y square is equals to 8x. Comparing this with the standard form of the parabola, y square equals to 4x, 4a equals to 8, a is equals to 2. So, let us take the slope form of the normal to the parabola. The slope form of the normal to the parabola y square equals to 8x is y is equals to mx minus 2am minus am cube is the slope form of the normal to the parabola y square equals to 4ax. So, but for this y is equals to mx minus 2am, 2 to the 4m minus am cube, 2m cube. But this normal is passing through, k comma 0. Substituting k comma 0 in this equation, we get 0 is equals to m into k, km minus 4m minus 2m cube is equals to 0. So if you take m here common, then k minus 4 minus 2m square is equals to 0. From this, m equals to 0 or 2m square minus of k minus 4 is equals to 0. Either m equals to 0 or this is equals to 0. This I have taken minus 2 as a common, then 2m square minus k square minus k minus 4 equals to 0. M equals to 0. If the slope is 0, so this is the slope of the x-axis. Therefore, one normal is the x-axis, which is the principal axis of y square equals to 8x. Now, let us, since this is a quadratic equation, it must have two roots. Let m1 comma m2 be the roots of 2m square minus of k minus 4 equals to 0. Sum of the roots and product of the roots. What is the product of the roots? m1 m2 equals to c by a, k minus 4 by 2. C by a. This is m square, m constant. So, minus of k minus 4 by 2 c by a. This is the form am square plus bm plus c equals to 0. So, m1 m2 are the roots. m1 plus m2, sum of the roots is minus b by a. Product of the roots m1 m2 equals to c by a. That is, m is absent here, c itself is minus of k minus 4 by m square quotient is 2. So, minus of k minus 4 by 2. So, but the remaining two normals are perpendicular to each other. Given that m1 m2 equals to minus 1, that implies m1 m2 is equals to minus 1 is equals to minus of k minus 4 by 2. That implies minus minus gets cancelled. K minus 4 is equals to 2 ones are 2. Therefore, k is equals to 2 plus 4 is equals to 6. Show that the locus of the point of intersection of the perpendicular tangents to the parabola y square equals to 4x is the directrix x plus a equals to 0. The pair of tangents drawn from px1 y1 to the parabola s equals to 0 is y square s1 square is equals to s into s11. So let px1 comma y1 be the point of intersection of the perpendicular tangents drawn to the parabola y square equals to 4x. So the equation of the pair of tangents from P to the parabola s equals to 0 is s1 square is equals to s into s11. So this also we have studied in the circles also. The pair of tangents drawn from px1 y1 to the circle s equals to 0 is also s1 square is equals to s into s11. Here also the same, but the notation will be differed. So s1 square, what is s1 for this? y1 minus 2a into x plus x1, this is s1 whole square is equals to s into s11. So y square minus 4ax into s11 is y1 square minus 4ax1. This is equals to a minus b whole square, a square. So y square y1 square plus 4a square x plus x1 whole square minus 2 to the 4 a y1 into x plus x1. This is equals to y square y1 square. So this is minus 4a x1 y square minus 4a xy1 square plus 4 4 is 16a square xx1. So y square y1 square y square y1 square gets cancelled on both the sides. Now the tangents are perpendicular. Coefficient of x square plus coefficient of y square is equals to 0. Ax square plus 2hx square plus by square equals to 0 represents two pair of straight lines, and if these two lines are perpendicular, then coefficient of x square plus coefficient of y square equals to 0, which we have learned before in the first year. So now what is the coefficient of x square here? So if you expand x square plus x1 square plus 2a xx1, so x square quotient is 4a square here. This is coefficient of x square, and the coefficient of y square is here 4ax1. If you transpose this side, 4ax1 equals to 0. So take 4a in common, then we will get a plus x1 equals to 0. So then 4a equals to 0, therefore x1 plus a equals to 0. Therefore the locus of p x1 comma y1 is x plus a equals to 0, which we need to show. Or we can do this problem in another alternative. So let us take the slope form of the tangent to the parabola y square equals to 4ax. The slope form of the tangent y square equals to 4x is y is equals to mx plus a by m. So this is equals to y is equals to m square x plus a by m if you find the LCM. Therefore m square x minus my plus a equals to 0 is the equation of the tangent in the slope form we get. This is the quadratic equation in terms of m. So let the roots be m1 comma m2. What are m1 m2? Slope of the tangents. So m1 plus m2, sum of the roots is equals to y by x minus b by a minus coefficient of m is minus y, minus of minus plus y by coefficient of m square is x, and product of the slopes m1 m2 equals to c by a, constant by coefficient of m square x. But given that the tangents are perpendicular, given that m1 m2 equals to minus 1 equals to a by x, so minus x equals to a, therefore a plus x is equals to 0 is the directrix x plus a equals to 0. Therefore the locus of the point of intersection of the perpendicular tangents is the directrix x plus a equals to 0.